Hey, I hope everyone is doing great. So, this time we're going to answer a basic yet important question. What is voltage? Now, we touched on this in the electronics crash course, but this time we're going to go into more detail. If you live in the US, you know that a typical power outlet puts out 120 volts. You may know that the battery in your car is 12 volts, and you probably know that the Arduino Uno has 5 volt and 3.3 volt outputs. But what does all this mean? What are volts anyway? If you're an electronics veteran, you likely already know the answer. If you're new, you may not really understand what voltage is. Either way, be sure to watch this lesson. If you're experienced, you'll get a good review. If you're new, you'll get some answers. So first, let's talk a bit about physics and some theory before we dive into a more practical idea of what voltage is. Specifically, let's go over potential energy and electric potential for a few minutes. Physics tells us that potential energy is the energy associated with the position or configuration of an object. For example, a compressed spring has potential energy. It has a potential to do some kind of work when it unwinds or releases. But when the spring fully uncompresses and comes to rest, it has no more potential energy and can't do any more work. Here's another example everyone is familiar with: gravity. Right now, the boulder has maximum potential energy. When it falls, it will have kinetic energy, and the potential energy will reduce as it gets closer to the ground, while the kinetic energy increases. Once it hits the ground and comes to rest, all the energy is used up, and it has no more potential energy. So, you may be asking something like, what's all this have to do with voltage and electricity? Well, another term for voltage is electric potential. This concept is a bit harder to visualize in gravity, falling objects, and springs. For example, the positive terminal on your car battery is at a higher potential, and therefore has more potential energy than the negative terminal. For clarification, consider this picture. Here we see two oppositely charged plates, just like a capacitor. The positive side has a higher potential than the negative side. Perhaps the negative side is at a lower voltage or ground, which is 0 volts, so it has less potential. Now, let's throw an electron in there. When the electron is at the bottom near the negative plate, it has high potential energy because like charges repel and opposites attract. This particle will gain kinetic energy as it travels towards a positive plate. Once it reaches the positive plate, the electron has 0 potential energy. Note that the potential energy of the electron is independent of the potential energy of the plates. The plates still have a potential difference between them before the electron comes into play and after it comes to rest at the positive plate. The electron scenario is similar to the rock. They both had 0 potential energy when they finally reached the ground. Note, however, that gravity is still there, just like the plates still had a charge on them after the electron came to rest. One more thing to remember: only differences in potential energy are meaningful. So, electric potential is a potential difference between 2 points. We'll touch more on this a bit later. Now that our theory is out of the way, let's talk about a more practical way to think about voltage. Consider this simple circuit. Here we have a series circuit with a battery, an LED, and a resistor. As long as the battery isn't dead, the LED lights up. The battery provides a voltage, or the electrical pressure. This pressure pushes current, which is simply moving electrons, through the wire, resistor, and LED, causing it to light. The resistor limits this flow of current. If we left it out of the circuit, the LED would burn bright for a while and then burn out due to excess current. As you may have already witnessed on your own, electronic components can be destroyed by excessive current. And since current flow generates heat, it can also be a fire hazard. To firmly grasp the concept of what voltage is, let's go to an analogy we're all familiar with: